Tomorrow will be better. And there's a question on the board. We are told that there is a car of mass this moving at an initial velocity this towards an obstacle. At the time the motion is being recorded, the car is 50 meters away from the obstacle. And the question says, find the braking force necessary to bring this car to a stop just upon impact with the obstacle. Follow me, dear friends. Solution. They are asking for a force. What's the formula for force? In accordance with Newton's second law, force is a product of mass and acceleration. We have the mass, which is this, but we do not have this quantity, which in this case is what I will call here a deceleration, because the car's velocity is reducing until an eventual stop. Okay, so now how do we use the information we have to obtain this quantity here, which we do not have? We have the initial velocity. I want us to pick an important information from the question, which is the final velocity. It's equal to 0. Why? Because the moment the car is eventually at a stop here, there's no more motion, so final velocity is equal to 0. So with this being said, we will use the final equation here, v squared equals u squared plus 2as. Now you're wondering, what permits me to use one of these equations of uniformly accelerated motion? I use this because I'm going on the assumption that the deceleration here is uniform, which means we wouldn't have a situation where it starts braking, it stops, and then it continues. We have a uniform braking until it eventually stops. This is why we can use this. And if you make A the subject of this formula, taking into account that V is already 0, then we will have that A is going to be equal to negative of u squared divided by 2 times s, the distance. Now numerically, we will have negative 25 all squared divided by 2 times 50. And if you currently punch this in your calculators, you have that A will be equal to negative 6.25 meters per second squared, because it's an acceleration. Now we have what we need to complete this formula. Therefore, the decelerating or the braking force will be equal to the mass 3, or rather 30,000 kilograms times negative 6.25. The negative sign is up to you whether you want to use it or not, but we have to bear in mind the fact that it's a braking force, so it's opposing motion, so that's why there's a negative here. If you correctly punch this should give us 187,500, this time around Newton, no more acceleration, because it's a force. And this is how simple it is. Tomorrow will be better.